Okay, guys, so today we're going to be covering chapter 10, which, as you can see here on my notes or on the week one that corresponds to the first chapter of the class. It's that entitled Solving Equations and Inequalities. It's on page 697 of your textbook. And just to cover some definitions, to clarify stuff, a variable is any letter that represents a different value depending on the equation in which it is used. We have the definition of a variable or a constant. A constant is a variable whose value remains the same throughout the use of a particular formula. Please make sure that you pay attention to the term particular formula. Different formulas will have the same variables, but they will have different values assigned to them. We don't have to worry about that for the moment because we'll cover some of those formulas in future chapters. Definition of an algebraic expression. An algebraic expression can often have variables, constants, numbers, operation signs, grouping symbols, and often exponents. The concept of simplifying can imply reducing to lowest terms and combining like terms. In the previous class, we covered a bit of that combining like terms or collecting like terms. We're going to go ahead and review that for the sake of this class in future sections as well. In evaluating is the solving of an equation whose variables have a predetermined value assigned to them. Solving is finding the value of a variable or variables in an algebraic equation. An equation is a mathematical sentence which states that the expressions on both sides of the equal sign represent the same value. That is key in solving your equations because, again, whatever you do to one side of the equal sign will have to be done to the other side, and I'll go into a little bit more detail as we proceed with the lesson. Single-step equations are equations that are solved performing a single mathematical operation. Just to clarify, mathematical operations would be adding, subtracting, multiplying, and dividing, for example. Multi-step equation is that which requires more than one mathematical operation to solve for the unknown variable. A coefficient is the number which is either being multiplied with or divided into or by a variable in an equation. And opposite operations are mathematical operations which are used in solving equations. And as I mentioned previously, addition is the opposite of subtraction, multiplication is the opposite of division, and performing a square root is the opposite of squaring a term. So we'll go over some of these terms or over these principles as we proceed with the chapters ahead in this course. In section 10.1, as you can see here, it's the addition subtraction principle, which is on page 698 of your textbook. And I'm just going to show you an example of what I mean of doing a single step equation here. Okay, so a single step equation would be an example such as having x plus 2 equals, let's say, 5. In order for us to solve this equation, we need to proceed in doing the opposite operations. We need to isolate the value of x, so we need to move that number that's next to it. If it's a plus, the opposite of plus is minus, so we do minus 2. And whatever you do to one side of the equal sign, you got to perform on the other side of the equal sign as well. So in this case, we subtract the 2 from the left. We got to subtract 2 from the right side as well. And a positive and a negative of the same value will cancel out. So we'll exit out here, we'll cancel it. And on the left side, we'll simplify just by having an x. And on the right hand side, we perform the operation of 5 take away 2 or 5 minus 2, which gives us 3. So that would be our answer there. Okay. Single step equations are fairly straightforward. They can involve either the addition principle, such as in this case we had a plus 2, or they could also be with subtraction concept, which is x, for example, x minus 2 gives us, let's say, 17. And in this case, if we have a -2 on the left side of the equal sign, which is preventing us, I guess you can say, from isolating the value of x. So the opposite of -2 would be +2. And remember that whatever you do to one side of the equal sign, you have to do to the other side. So in this case would be +2. These two values, the -2 and the +2, cancel out, thus leaving us with x. And x is going to be equal to 17 plus 2, which gives us 19. Okay, again, those of you that have had a previous algebra class might find this a little too easy, too boring, perhaps, but we're going through the motions, and eventually we're going to go ahead and piece these concepts together. So give me 1 second. Let me erase this here in hopes that I don't drop my board. Okay, let's see. Okay, so that's pretty much the gist of chapter 10.1. In addition to 10.1, let me see here, we have so we covered the 10.1, which was addition and subtraction, with section 10.2. 10.2 deals with, I don't know if you can see it here, it's kind of blurry, I apologize. It's the multiplication division principle. So those of us that have had the class course, we kind of remember that we touched slightly on these on this concept. And for example, let's say the multiplication principle in this case would be, let's say 3x equals, let's go with 15 here. Okay, so we have 3 times the value of x, or the unknown value of x, will give us 15. Some of you might say, well, professor, come on, this is too easy for me. 3 times 5, it's obviously, but yes, that's going to be easy to solve, mental math, but you're going to get to situations where you might not be able to do it mentally. Again, we're just explaining the concept and eventually piecing it together as we move on in further chapters. Okay, so again, anytime you see a coefficient next to a variable and there is no mathematical symbol in between them two, that implies that it has been multiplied. In this case, we're going to perform the opposite operation, which in this case, the opposite operation of multiplication is going to be the division. Okay, so with division here, we're going to divide both sides of the equal sign by 3. And remember, keep in mind again, I cannot reinforce it enough. Whatever you do to one side of the equal sign, you got to do to the other side as well. So in this case, one thing that needs to be remembered is that whenever you have the same number over itself, you can say algebraically that they cancel each other out. Think about it, or remember that 3 divided by 3 is equal to 1, and any number or any variable multiplied by 1 is just the same number itself. So that's why when in algebra we say that whenever you have a variable over itself, I'm sorry, a coefficient over itself, or the same number in numerator over the denominator, the same denominator, it cancels out. We are left with just x, and we perform the operation on the right hand side, which is 15 divided by 3, which gives us 5. Okay, and in this case, again, please, I cannot reinforce it enough. Show your work and box your answers, so that way it'll make it easier for us. Now let's proceed in doing an example so that we can show the concept of we showed multiplication, now let's show division. Okay, so we have, let's say, x over 4 equals 28, for example. And in this example, I know that some people will not like fractions. Some people will say, oh, come on, mister, just as I was getting the concept of it, you're throwing me a curveball here, and you're throwing in fractions. One of the beauties about math, or one of the cool things about math, is that there's always a way to manipulate numbers so that you're able to cancel it out and make your life a little less complex. So in this case, what I tell students is that if they could, what number can be multiplied into this particular equation so that it clears out that fraction. So again, by us clearing that fraction, what I mean is that we're going to perform the opposite operation of division. So we're going to multiply the entire equation by 4. Okay, so in this case, if we apply the rules of the distributive property, you're distributing this 4 to the first term, or the first component of that equation, and you're also distributing it to the second term, or on the right side of the equal sign. So just for simplification's sake, or for to show you the process, you would have 4x over 4 equals, and we'll do it on the side here, 28 times 4. So 4 times 8 is 32. We have a 2, we carry a 3. 4 times 2 is 8, plus 3 is 11. So here we have 112. And again, as we mentioned in the previous example, whenever you have a number over itself, it cancels out. So your answer would be x equals 112. Okay, there we go. Okay, so now let's see this here. Let me. Okay, let me see, where did I leave my eraser now? Here we go. Okay, so I'm gonna go ahead and erase this stuff here so that we can continue with the lesson. I apologize, guys. We're trying to improvise here with the magic of television. It doesn't work that way in under the circumstances. Okay, so now that covers pretty much section 10.2, and section 10.3, it says that it's actually entitled using the principles together. These two previous sections, 10.1 and 10.2, can be considered single step equation, or one-step equations. With the next one will be multi-step equations. So we'll do an example here to show you what I mean by that, and some of the rules or procedure on how to solve multi-step equations would be to you're first going to move the non-coefficient number in the equation to the opposite side of the equal sign, and then the second step would be to move the coefficient to the opposite side of the equal sign. Okay, so let me show you with an example. That way you won't say, well, what do you mean? You're speaking, but you're not showing me. So here we have 5x plus okay, so here we have the expression of 5x plus 7 equals 42. The way you would solve this, according to what the procedure that I explained to you a few minutes ago, was that the first number that you're going to move, quote unquote, would be the 7, which is not the coefficient. Remember, the coefficient is the number that's right next to the x, or the variable, in this case x. So the opposite operation of plus 7 would be negative 7. So remember, whatever you do to one side, you do to the other. These two cancel out, so we're left with 5x equals, what's 42 minus 7? It's 35. And we do the division now, because remember, the opposite operation here is of 5 times x would be division by 5. So whatever you do to one side of the equal sign, you do to the other here as well. 5 over 5 cancels out, and we're left with 5 equals 7. And there is our answer. If you want to make sure that you did this correctly, you can always go back and plug in this 7, or this value that we discovered or that we solved mathematically for x, and plug in that value into the original equation. In this case, if we do it mathematically in our heads, it would be 5 times 7 would be 35, plus 7 equals 42. So 42 would equal to 42 on both sides of the equal sign. Thus, the number that we discovered for the value of 7 makes it a true statement. Okay. Let me see here. Okay, now you're going to come across instances where you will have variables on both sides of the equal sign. In situations like that, what I usually tell students is that some people don't like to work with negative numbers. Some people get confused with carrying the negative sign. And one of the jokes that I made with students was that that's why the Challenger blew up, because someone didn't carry the negative. Unfortunate as it sounds, it is that important. It's a crucial concept of carrying that negative sign throughout your equation. So I'm going to go over one of the problems that has variables on both sides of the equal sign, and I'll show you what I mean as I go through it. Okay, so we're going to use 3x plus 7 equals 2x minus 24 equals 2x minus 24. Okay, sorry, here we go. Okay, so in this case, guys, as you can see, we have variables on the left side of the equal sign as well as on the right hand side of the equal sign. And one of the ways that I tell students to proceed, or to make your life a little easier and not get confused with negative variables, keep in mind that whenever you're trying to solve or find the value of a variable, the variable always has to be positive. That's why I proceed in the way that I usually tell students to do the following. What I tell students is this: that if there are variables on both sides, move the smallest number of variables to the side of the equal sign that has the most. In this case, we know that there are variables on the left side, 3x, on the right hand side, 2x. So we're going to move that smallest number of variables, in this case the 2x. If it doesn't have a sign in front of it, it automatically is implied that it's a positive. So in order for us to move any number across the equal sign, we're going to do the opposite operation. In this case, we'll do minus 2x, and whatever you do to one side of the equal sign, you do to the other side as well. So minus 2x. So positive 2x, negative 2x cancel out. We are left with negative 24. And on the on the left hand side, we have 3x minus 2x, which gives us just x, and we bring down that positive 7. Okay, so now we are back to a single step equation in which we carry out the negative operation, or I'm sorry, the opposite operation of plus 7, which is negative 7, and negative 7. So in this case, our answer would be negative 24 plus negative 7, or you can phrase it as negative 24 minus 7. So remember that when you're working with positives and negative numbers, the way that I like to tell students is to to avoid any confusion, think of it as money. Anytime you see a negative number is money that is owed to you. So for example, in this case, someone owes you $24 and then you let them borrow an additional $7. So now they owe you a total of negative 31, right? That negative would be the place of the word they owe. So your answer in this situation would be x equals negative 31. Okay. Okay, I'm going to erase this here from the board because I'm going to show you another example as well. Give me 1 second. Okay, the next example is going to be a little bit, again, throwing you a curveball here. It'll be the next example we're going to cover is 4x minus 40 equals negative 8x plus 20. Okay, give me 1 second here so I can step back. Okay, so here we go. Again, going back to what I mentioned previously, that if you have variables on both sides of the equal sign, you are going to be moving the smallest number of variables to the opposite side of the equal sign. So here again we're using the same variable of x. We have 4x on the left hand side and we have negative 8x on the right hand side of the equation. Now keep in mind that if a number is negative, it's going to be way smaller than the value of 0 on forward towards the positive side of the number line. Okay, so in this case, to moving the number of the smallest number of variables to the side of the biggest side of variables, biggest number of variables, I'm sorry, you would move the 8x, the negative 8x, I'm sorry. So the opposite of negative is positive, 8x. And you do that to the left side. So here, in combining like terms, I'm going to throw that in here now so that you can get introduced to the concept. In order for you to collect like terms, the one thing that you always have to keep in mind, one is that the variable has to be the same. In this case it is. And very, very importantly is that the exponent, which it'll normally be on top of the variable itself, it also has to be the same. In this case, again, if it doesn't have an exponent, it is automatically implied that it's an x to the first power. Okay, so if we combine like terms with the 4x and the 8x, it would give us 12x, and we bring down minus 40. This is a 40, okay? And we said that the negative and the positive here cancel out, so we're left with 20. Now we come back to still a multi-step question here, and we're going to be moving this 40, negative 40, to the opposite side by adding 40 to both sides, the opposite operation, guys, remember? And we add 40 to the right hand side. So negative 40 and positive 40 cancel out, which leaves us with 12x equals 60. And again, the next process is to, if the variable is being multiplied by 12, the opposite operation would be to divide by 12 both sides of the equal sign. 12 over 12 cancels out, and we're left with x is equal to 60 divided by 12 gives us 5. Okay, now again, if you're able to do your mental math, power to you, but for the sake of this lecture or this lesson, I need you guys to show the work. That way, if there is any kind of confusion, I can see it and maybe bring it to your attention and clarify if there are any doubts on how to proceed. So just to review this example, we have variables on both sides of the equal sign. here is the 4x, and here we have the negative 8x, and we brought the smallest. So remember that negative 8x is smaller than a positive 4x. Even though the 4 is smaller than the 8, by it having the negative 8, the negative symbol in front of it, that automatically makes it smaller. Okay? So I'll take a little step back here so you guys can see the whole process or the whole problem being solved. Okay? Sounds good. Okay, let me erase this here. Okay. Okay. Now, keep in mind, guys, that if there are the exact amount of variables on both sides of the equal sign, this will result in the equation not having a solution. Okay, so you're probably wondering, okay, Mr. Ojeda, what do you mean by that? Let's say we have 2x plus 3 equals 2x plus 4. Actually, let's make a negative 4 so that we can see. Okay, so remember what I mentioned previously, that if you're trying to if you come across an equation that has variables on both sides of the equal sign, you're going to have to collect like terms or bring the variables to a single side of the equal sign. So in this case, it doesn't matter if we bring the variables on the right hand side to the left hand side and proceeding with attempting to solve the equation. So let's say, for example, we want to move this to the left side of the equal sign. Remember that if it doesn't have a sign here in front of that coefficient, it's positive. So we subtract negative 2x from the right side, and we do the same thing on the other side, negative 2x. So now look, this is what I mean, that it will result in an equation not having a solution. Positive 2x minus 2x cancels out. On the right hand side, we are left with negative 4. And on the left hand side, we have positive 2x minus 2x cancels out, and we are left with a positive 3. Keep in mind that the process of solving an equation is in assigning or finding a value for x, and again, the definition of an equation states that the left hand side would have to have the exact same value as that on the right hand side. So as we can see here, there is no way that positive 3 can equal negative 4. So in this case, we would draw a line through the middle of the equal sign, which implies that it is not equal. And if you were to come across a problem like this in your homework, your answer would be no solution. Okay? Okay, let me see here. Okay, now another curveball that algebra will throw in your direction is going to be the incorporation of decimal numbers and equations, where in order for you to proceed in solving that problem, you need to clear that decimal by multiplying the entire equation by a power of 10. Okay, so as you can see here, we're going to go ahead and proceed with that example. 1.25x plus 2.5 equals 0.2. So let me write that down on the board. So 1.25x plus 2.5 equals 0.2. Okay, guys, and I apologize. I know that you guys might probably feel like you're watching that movie, The Blair Witch Project, where the cameraman was shaking their hand so much. Again, we are we are working with the lemons that life has handed us in the meantime because of this whole situation that we're going through, and for the sake of your health and that of us, the staff, I thank you for being patient. So here, in order for us to clear or get rid of those decimals, we need to see what power of 10 we need to multiply the entire equation by to clear that decimal or to get rid of that decimal. So normally what I tell students is the following. Please look at how many places are on the right hand side of each decimal, and we'll proceed that way. So for example, what I mean is this. In the first term, the coefficient here, it has 1, 2 places. The second term, it's only one decimal or one space after the decimal, and the final or the last term has only one number after the decimal itself there. So what we're going to do is the following. We need to multiply by a power of 10 to the second power. How do I get that? Is we're multiplying by a power of 10, and it will be 1, 2. We need to go with the highest number of spaces to the right of the decimal point so that we can completely clear all of them. If we were to just do 1, for example, moving the decimal one place, it would still continue giving us a decimal. So it would be 12.5 x plus 25, because we would move the decimal here to the right of the 5, and this would give us 2. Again, we need to clear the entirety of that decimal point. So if we move this decimal point 2 places, that will give us 125x plus 1, 2. That would give us 250. Whenever there isn't a number that corresponds to that place, we add a 0 to it. And here it would be 1, 2. And we would add a 0 to it. So again, it was 1 movement, 2 movements, and it would be equal to 20 there. Okay? I'll let you see that. Okay, and we proceed as we would normally do with the multi-step problem. We need to move the number that is not the coefficient, so it's negative 250 on both sides. That cancels out, so we have 125x is equal to, someone owes you $250, right? The negative, and they pay you 20, right? Because the positive. So how much do they owe you still? 230. Now we need to divide by 125 on both sides of the equal sign. And let me see here. Did I do this with the magic of television? No, I don't have the answer with the magic of television, so that means that we can reduce, actually. Let's reduce these terms here. It could be divided by 5 on both sides, so we'll do let's divide by 5 to simplify it. So that gives us 46 and over 25. Okay, and then we would proceed in dividing the 46 by 25 to give us an answer in a decimal format. So let me go ahead and erase the top part so that I'm able to proceed with giving you guys the answer as a decimal. Okay, give me 1 second. Let me grab my my makeshift eraser here. Okay, so what we'll do is we're gonna go ahead and divide 25 into 46. So it would be 25 and 46. How many times does 25 fit into 4? It's 0. So now we go to 46, and if it's only one time, 25 times 1 is 25, and we subtract, it gives us 21. So we need to have decimal, so we put a decimal point here and a decimal point on the top, and we proceed in adding at least 2 zeros. So we bring down that 0. So now we're going to divide 25 into 210. Let's think of it, for the sake of this problem, as quarters. So there are a total of 8 quarters in $2. So that gives us 200 pennies, or 200. We subtract and we continue bringing down that 0, and it would be, how many times those 25 fit into 100? It would be a total of 4. And 25 times 4 gives us 100. And there it is. So your answer for that equation would be x is equal to 1.84. Okay? Now, let's say that, for example, if our answer was 1.84237, let's stick to 2 places after the decimal point. Okay, round to the nearest hundredth, and that will make it a lot easier for you. I don't expect you to carry more than 2 significant figures. The significant figures would be the 100th place in this case. Okay, so let me erase that here. Okay, and as I mentioned, we went over clearing decimals, so we also need to clear the fractions as well. So for example, let's say we have the following problem. Okay, so we have 3x over 4. Okay, so let's say we have that problem here. We have 3x over 4 plus 1/2 equals 5/8. I told you guys that once you start getting comfortable with a concept in math, algebraically, they'll throw you a curveball to make your life a little more interesting, shall we say, instead of complicated. I don't want you guys to see math as something that is difficult or unapproachable. Remember that it's just math is just the process of using plus, minus, multiplication, and division. Okay, and you guys have been working with those operations since elementary school or even kindergarten. Okay, so in this case, whenever we have 3 different denominators, we need to find the common denominator between the 4, the 2, and the 8. If we were to choose, if we were to look at these 2 numbers, yes, the common denominator would be 4. However, the 4 and the 8 are not, wouldn't be able to function with that common denominator of 4. So we need to go a number higher. In this case, the common denominator between 4, 2, and 8 would be the number 8 itself. And what we're going to do is we're going to distribute 8 into the whole equation. Okay, we're going to distribute. So what we're going to do here is we're going to distribute the 8 into the 3x, into the 1/2, and also to the 5/8. Okay, remember my Costco example, or the methodology that I went over with you guys at some point, that the distributive property works as that person at the Costco line handing out samples, and they're going to distribute it to every single part of that group that's been waiting patiently. Okay, think of it as that. So now we do 8 times 3, it gives us 24x equals, over 4, I'm sorry. We have here 8 over 2, and we have 40 over 8, right? You're probably wondering, well, didn't you say that we were going to get rid of that fraction? Why do you still have the 4, the 2, and the 8? Yes, you're very right. We are getting rid of that fraction, and I'm going to show you right now. So how many times does 4 fit into 24? It's 6 times. How many times does 2 fit into 8? 4 times. And how many times does 8 fit into 40? It's 5 times. So as you can see, now we have come to a much simpler, I guess you can say, way of solving this problem and turning it into a multi-step. And now we proceed as we have done in the past, which is the -4, or moving the number that's not the coefficient. So we have 6x is equal to +1, and we divide both sides by 6. So we are left with x is equal to 1/6. Okay? So yes, it is a process of many steps, but I need you guys to remember, if you have to write them down, or if you have to go through the motions, that way you get used to the process, and then eventually it'll come to you as a second nature to proceed in canceling the equation, or clearing the equation, I'm sorry, of any variables, of any fractions, any decimals, and then eventually proceeding in solving the equation itself. Okay, so let me show you here again. We determined that the common denominator between 4, 2, and 8 would be 8. So we distributed that 8, the common denominator, to all of the terms inside of that parentheses, which is the original equation. Once we did that, we were left with, meaning 8 times 3 gives you the 24x. 8 times 1 gives you the 8 up here. 8 times 5 gives you that 40 here. And then when we still carried the denominators on the bottom, we proceeded in solving or simplifying. 24 divided by 4 gave us 6. 8 divided by 2 gives us 4. And 40 divided by 8 gives us 5. Okay? And those multi-step problems were some of the ones that we had covered previously in section 1 and 2 of this chapter, and also in the later chapters of the previous course as well. Okay. And I was just going to ask you guys, are there any questions? The force of habit of being in front of a classroom. I apologize. So if you have any questions, you can either list it as a comment on the video, or better yet, if you put it on Populi, or shoot me an email to clarify some of this, some of the process of working with fractions, or clearing the fractions and clearing the decimals. Okay, and also the students in the class, please do not forget that Hannah is available for tutoring. Coordinate with Hannah, and if you don't have Hannah's number, please get it from Dr. Chappell, or Dr. Brubaker or myself by shooting me an email, okay? Now, we're going to be looking at chapter 10.4, or section 10.4, I'm sorry, which is the formulas, and it starts on page 721. So as you can see here, as much as I'm trying to focus it without moving it too much, I don't want to have anybody suffer from motion sickness. I have the formula is the quote-unquote recipe and set of instructions for solving a certain type of calculation. Now keep in mind that the derivation of a formula can also be used to find a specific unknown when the value of other variables within that formula are known or provided to evaluate. Evaluating means to solve an equation with predetermined values assigned to the variables. Okay, so one of the formulas that we're going to be looking at, just for the sake of the example, would be the distance formula, which is d equals rt, right here in the middle. Okay, so let me show you here. Okay, so just to clarify, d equals okay, so here we go. The definition of each term is d equals distance, r equals rate, and t equals time. So for example, what sometimes an example that they would ask you, or a problem they would ask you to do, would be, they'll say solve d equals rt for t. Okay, so whenever they give you this, let's say for example this problem or this question, what they're technically telling you to do is to from this formula here isolate the value of t. And you're going to say, well, wait a minute, there are no numbers, so how can I isolate the value? How can I find the value? Remember what the definition of formula was, is the recipe and the procedure of determining a specific value. So here, let me write this down here so that we can make it easier to work on it. We're trying to isolate the value of t. So t, if you think about it, it's being multiplied by r, correct? So we perform the opposite operation of multiplication. In this case, it would be division, right? We would divide everything by r. And now look, r over r cancels out, right? And now we're left with t is the same thing as d over r. So you're able to find, using that formula, the distance formula, you're able to find the time it took for a specific movement if you were to be given the value of the distance and the value of the rate. Now, how about if they were to tell you, use solve d equals rt for r. So again, right, we're going to try to isolate the value of r. So we're going to, here on this side, we're going to divide by t, and these get canceled. So distance over time is equal to the rate. Now think about it, guys. A rate is like let's say one of the common rates that we are used to is, let's say miles per hour, right? So the distance is measured in miles, and the time would be hours. So a car was traveling at a rate of 30 miles per hour. So there we have the miles, the measurement of distance, and the measurement on time on the bottom. Okay, so one of the things that I like to tell students is the following, that you are not making any changes to the value of the d, the r, or the t. All you're doing is rearranging the formula itself. The original formula was d equals rt, and here we did a derivation of that formula so that we are using it to find the unknown variable, or the unknown variable in that equation when we have our given the distance and the rate. And on the right hand side here, we isolated the value of r so that if we're given the distance and the time, we are able to find the rate for that particular problem. Okay. Okay, now on chapter 10.5 is the application of percentages, and we need to, I'm going to explain to you guys, go over this process of finding the percent of a particular number, or the value. Okay, so let me erase this here on the board. And I thank you guys for being so patient, and for not getting motion sickness. I guess next time you guys watch the video, I'm gonna have to put a disclaimer that you guys gotta take some Dramamine, so that way you guys don't get a motion sickness from watching my video here. Okay, so keep in mind that percent is is pretty much a ratio. A ratio in the form of a fraction. Wait for the camera to focus itself. Okay, so when finding a percent of a number, we need to use the two formulas that are listed here on the top, which is the percent over 100 is equal to is over of, or percent over 100 equals part over whole. Okay, so I'll write them down on the board, so maybe you can probably have a better way of seeing it. So we have percent over 100 equal is over of, or a variation of it would be okay. So keep in mind that again, a percentage is as I mentioned earlier, is a ratio, and 100% is the complete number, or the complete portion. That's why I have it as part over whole, because a percentage is a piece of an entire number over 100. Okay, so a common problem that you guys will find in determining percentages would be, let's say for example, what is 15% of 45? So okay, so the one thing that you guys will always know how to plug into the formula would be the 100. That's always there. Okay, so now all we got to do is think about it. We are given the percentage, right? The percentage goes on top of the 100, right? Such as in the question here, in the formula. So we would put the 15 on the top here. And then as we proceed in reading the question here, it says what is. So the is the unknown, right? So we'll put an X right there. And 45 is the entire whole, or the of. Anytime you have of, the number that precedes it would be what will take the place of the in that formula. So we would have 45 here. Okay, so our formula would be or our proportion would be 15 over 100 is equal to x over 45. How do we solve for this? We cross multiply. So we're going to multiply the 100 times the x, which gives us 100x, and then we are going to multiply the 15 times 45. Sorry, trying to juggle everything here, guys, I'm sorry. Which gives us 15 times 45 gives us 675. And now, in order for us to proceed in solving that or isolating the value of x, we divide by 100, divide by 100, cancels out, so we're left with x. One trick in dividing any number by a power of 10 would be to, the decimal point is here on the right hand side of the last number, and as you're dividing by 100 here, it'll be by 2 zeros, so you move this decimal point 2 places, so your answer will be 6.75. So now you can say 6.75 is 15% of 45. Okay, so going back through the process again, first we determine which formula, which of the two formulas we were going to use. The percentage over 100 is equal to is over of, or percent over 100 is equal to part over whole. Okay, so we determined that with what we're given as part of the question, the best option would be to use this equation here, or this formula, and we just plugged in the numbers that we were given. In this case, we had the 15%, which we listed it where the percent symbol goes, as in this case here. And then we were also given the value of 45, which corresponds to the denominator on the right side of the equal sign, such as in this case here. We proceeded with cross multiplying 100 times x, and then 15 times 45, which gave us 100x equals to 675. And in solving or isolating the value of x, we divided both sides by 100, and that's how we got the 6.75. Okay. Okay, so I'm going to erase this here. Okay, another example or another method or another way of them approaching you about a problem similar to what we've covered so far would be the hold on guys, I'm trying to juggle here. It would be 30 is 10% of what number? So let's say 30 is what percent of, oh no, I'm sorry. 30 is, I'm sorry, I apologize guys, I'm so sorry here. 30 is 10% of what number? I'll just be lazy here, I apologize. Of what number, right? So look, here we have again, right, the percent, we have the word is, and we have the word of, right? So what we're going to do is we're going to use the first derivation of the formula. So we'll have, we have 10%, which will go on the location of the percentage here. So it'll be 10 over 100 is equal to is, 30 is, which is 30 here, and of what number, right? The of is the unknown because we don't know what number it is, so we'll put an x here on the bottom. And again, we go through the same motion, right? So 10x by cross multiplying is equal to 30 times 100 will give us 3,000. Okay, and we divide by 10, so we are left with, when you're dividing a number with zeros, if you have a 0 on the bottom, 0 on the top, cancel it out, and then it's 300 over 1, which is your answer there. Okay, so if you were to plug in that value that we found of x into the original question, you can say that 30 is 10% of 300, because that, what number would be the 300 that we solved out here. Okay, so I'll let you guys see that right there. Okay, and I'm gonna erase this here now. Okay, and in this next part of section 10.5, we're going to be looking at the percent increase or percent decrease. Now, the percent increase and decrease is the percent in change in an amount to determine what value went up or what value decreased. The example, or actually the rules in determining or in calculating the percent increase, it says subtract the original value from the new value. You're going to write a ratio to show the amount of increase to the original value. And then you're going to convert this ratio fraction, this ratio fraction to a percent. Okay, what do you mean by that? Okay, so let's look at the example that we have here. It says Chantal earns $175 per week. She got a raise and now earns $225 per week. Find the percent increase in her salary to the nearest whole. Okay, so according to the instructions, we have two values, right? The old value or the original value and the new value. So I'm going to write those down. Okay, so then the original, I'll put it here, original, and I'll put new. Okay, and I just dropped my marker cap. Sorry. Okay, so we said that the original amount that she was earning was 175 and the new one is 225. So 175 would go here and 225 is the new one. And we're trying to find the percent increase. There we go. Okay, so we're going to subtract the original from the new. So in this case, you're going to do 225 minus 175, right? So it'll be 225 minus 175, which gives us 50, right? And then the second step in determining this this percent increase is to, it says write a ratio to show the amount of increase to the original value. So the amount of increase in this case, it was 50 over the original value. So it's 50 over 175. So it would be 50 over 175. That's the ratio. So this is step 1 here. Step 2 is, okay, let me take a step back so you guys can see everything. So the original amount that she was earning a week was 175. She got an increase. Now she makes 225. So the first step was to determine the amount of increase, which was 225 minus 175 gives us 50. We are going to write a ratio of the amount of the increase, which is the 50 on the top here, over the amount, over the original amount, which is the 175. Now what we do is we are going to convert, for step 3, we are going to convert that 50 over 175 to a percent. And it would give us, if you divide 50 by 175, it gives us 0.2857. Okay, so when you divide 50 by 175, it gives us this number here, and we are converting this decimal to a percent. So I'll put a little arrow to a percent. And whenever we convert a decimal to a percent, what we need to do is we need to move this decimal point 2 places to the right. And the question asked to find the percent increase to the nearest whole. So what we need to do is, okay, let me see here, where's my marker? Oh my goodness. Okay, so we move this decimal point twice. So 1, 2. So it would be about 28.57%, but we need to round to the nearest whole. So we underline the whole and look at the number that precedes it. In this case, if the number that precedes the number that the value at which we are rounding, if it's a 5 or higher, that increases this number by 1. If it was a 4 or lower, it becomes a 0 and it just stays the same way. So your answer would be this little squiggly equal sign. It just means about 29%. Okay, so to wrap it up, or to answer or get the concept, is that Chantal got a 29% increase in salary from earning $175 a week to earning $225 per week. Okay, so again, just to wrap it up or to review it, we say that we find the difference in value of the increase by subtracting the original amount from the new amount, which gave us 50. We set it up as a ratio of the original, of the amount in change over the original amount. And then we convert this ratio to a decimal, and in turn we convert it to a percent. Okay, so I'll step back here so you guys can see what it covered. Okay, so far I hope it's so far so good, and I expect questions, guys. If you have any questions, please don't be shy and ask questions. Okay, and if you guys get shy in asking questions, close your eyes. Your fellow classmates will not see you if you close your eyes. Okay. Okay, and in calculating the percent decrease, it would be the same process. It just would be involving the amounts, such as you would actually, here it is. Sorry, I moved it too quick. Okay, so you subtract the new amount from the original value to calculate the percent decrease. You write a ratio to show the amount of decrease to the original amount, and you convert this ratio to a percent. So here we have an example that I have in my notes, is that Alexa's work hours were reduced from 40 hours to 28 hours a week, and it says find the percent decrease of hours in Alexa works. So I want to show you guys that. So its original amount is 40 to the new amount is 28. Okay, so we subtract the new amount from the original. So again, it will be the same thing, right? So we're going to subtract from 40, we subtract the new amount, which is 28. So 40 minus 28 gives us 12. That's step 1. Step 2, we set it up as a ratio, right? So 12, the amount of the change over the original, which is 40. And then we convert this ratio to a decimal, which is 0.30, right? Because 4 times 3 gives you 12. That would be a way to a little shortcut. And then we convert this decimal to a percent, which would be a 30% decrease. Okay, so again, the original amount of hours that Alexa was working was 40. She got a reduction, and now she works 28. So we determine that the amount of the change is 12. We set it up as a ratio of the amount of change over the original amount. We convert this ratio, this fraction, to a decimal here, and then subsequently we make it into a percentage, and that's how we get the 30%. Okay, so let me show you guys all the way here. Okay, now the next section, guys, is a 10.6. With 10.6, it's called applications and problem solving. One thing that I cannot emphasize enough is for you guys to read the word problem itself. Read it at least a couple times. Read it very detailed, because they'll try to give you information or numbers that are not pertinent to the problem itself. I suggest you familiarize yourself with the question or the problem and situation that it involves. Convert the problem to an equation, solve that equation, and then check the answer by plugging in the value into the original problem. Now, one example that I kept on mentioning to the students in the last class was that I had a student one time tell me that they were working on a problem that stated how fast, or I think it asked how fast is the airplane going with relations to traveling to a certain location. And the student said, "Hey, mister, I get an answer that the plane is flying at about 150 miles per hour. So I told him, I said, okay, well, what I need you to do is think about it. If you and your friends are being irresponsible and driving on the freeway at about 100 miles per hour, are you guys pretty close to flying? And he said no. So that's what I mean by checking the answers, by plugging in the values to the original problem. See if it's realistic. Okay. 10.7, well, 10.6, it's going to be pretty much using the concepts that we've been working with and applying them to the problem solving methodology. Okay, so that should be, it should be a bit more interesting. I don't want to say difficult or complex, because again, it's just translating from English to algebra, and eventually using adding, subtraction, multiplication, and division. So with inequalities now, we're going to be using, if you guys look at the first bullet point here, the meanings of the inequality sign. If we have x is less than y, it means that x is less than y, and when it's graphed, you would use an open circle. Just listen to my madness for the meantime when I say open or closed circle, and I believe in the second, either the second or third week of class, we're going to go into more detail as to what that means in open or a closed circle. Okay. One of the things that I learned when I was younger, I don't know if it was during Moses' time or one of the time of the pharaohs, they taught us that the little inequality sign, you would pretend it to be a crocodile, an alligator, and it would eat the bigger number. So in the second bullet point here, I have x is greater than y. Notice how the third one here, it has x greater and then a little line on the bottom, which just means it just means that it's greater than or equal to. And the last bullet point, I have it as x is less than or equal to y. Okay, so I'll have it here like this. So x is greater than y, and if it has a little line on the bottom, it would say that it could, this number could also be equal to this other variable here, or it would fit within that category. Okay, so those are just terms to keep in mind. We'll use that. We'll use them in previous in future chapters, and we'll go over it into a little more detail. This is just a brief introduction of that of the concept of inequalities. Okay. In solving inequalities, guys, we treat the inequality sign just as you would a an equal sign. So let me show you what I mean by that. So let me erase this here. Okay, so we have x, the way that you will read this problem is x plus 4 x plus 4 is less than 12. So that means that the value we're going to get for x, it has to be less than 12. Okay, that's the challenge, quote unquote, that we are being presented with right now. Okay, give me 1 second so I can grab a different color marker, not a market, sorry. Okay, so what we need to do here is, again, right, in order for us to isolate the value, we have to move this 4 to the right side of the inequality sign. So by doing the opposite operations. Okay, so plus 4 minus 4 cancels out, and we are left with x. We bring down the inequality sign as it is, and then we subtract the 4 from 12, which gives us 8. Now think about it. Is the 8 less than 12? Sorry, my furry hand's in the middle. So is the 8 less than 12? Yes, it is. So our answer is correct, and therefore this inequality is true. We cannot say that, hypothetically, we cannot say that if we were to get an answer of 16, 16 cannot be less than 12. That's what I mean by looking at realistic expectations, okay? Or realistic answers. Okay. Okay, so now we're going to look at for example, the following here. So we have 5x 5x is greater than 120. And in this case here, the coefficient is multiplying with the x is 5, so we divide both sides by 5 here, and the coefficient cancels out and we're left with x is greater than 24. Now you're going to say, Professor, in the previous example you mentioned that 24 would be applying to this value here and it would be greater than 120. In this case 24 is not. However, the way that this inequality would be true is that if x was any value bigger than 24 and it was multiplied by 5, it would give you a number that would be greater than 120. Okay, so that's what it pretty much is saying, that any number after 24 as it's substituted into this original equation, it would make it a true statement. Okay, so I'm going to erase the left hand side here, or actually the problem, so I can show you guys another example here as well. Okay, so the next one is, okay, the next problem that we're going to be looking at is dealing with inequalities that have a negative. Okay, so we'll do this problem here. The negative 5x plus 7 is less than or equal to 42. So negative 5x plus 7. Negative 5x plus 7 is less than or equal to 42. Okay guys, so this is the problem now the inequality that we need to solve. And again, we're going to be working with, notice how we have introduced a negative coefficient, and we have a the less than or equal to. This less than or equal to, it doesn't matter if it's just a straight less or a straight greater or a straight greater than or equal to. We proceed the same way as an equation. So what we need to do is we need to move this 7 to the other side of the equal sign, or the inequality sign, by doing a minus 7 on both sides. So we are left with negative 5x is less than or equal to 35. And now here comes the key part. Whenever we move a negative, we divide by a negative in an inequality, this inequality sign is going to switch. So for example, here we're dividing by a negative 5 and divide by a negative 5. These cancel out, the x is brought down, but now this, instead of being less than or equal to, it would become greater than or equal to negative 7, right? Because we divided 35 by negative 5. So again, guys, please notice that when you divide by a negative number across an inequality sign, that inequality sign automatically switches. So it went from less than or equal to, it went to greater than or equal to 7, negative 7. Okay? And I'll let you guys see the whole problem there. Okay, and for the most part, that covers up the chapter. I thank you guys for being patient. I would appreciate any feedback you guys can give us as to the process of having the lesson delivered to you guys this way. And I hope you guys have a great day. And if you have any questions, do not be shy about asking Dr. Chappell for my email, or to even contacting Hannah for assistance. Thank you and have a great day.